that's it, guys. Here you go. Here's the finished Arbor. I mounted it in the mill, and it has 2/1000 of runouts. Welcome back to the shop, guys. I'm Brad. Today we're going to make an R8 Arbor out of this piece of 1045. Now originally I'd made one and I was going to release a video showing how to do it, but it didn't come out to my standards. I was plagued with a bunch of issues. A lot of them were camera angles, bad footage that I wasn't happy with, and I had another issue with my tailstock. I don't know how it happened, but my tailstock was out of alignment by 0.005 of an inch, and I discovered it halfway through the project. So you know, the Arbor came out fine. There was a little tiny bit of runout, so I did a little research. I had some comments and some suggestions, so I found a way that we're going to eliminate any runout and make it perfect. So sit back, this one's going to be a good one. We're going to get it done a lot faster than the prototype, we'll say. Before we begin, one of the things I'm going to do is I'm going to mount a test bar on here, run an indicator on, and make sure everything is good to go. For that, I'm going to just give the machine a quick little wipe down, make sure there's no grit from any polishing that I did. Because that's the thing that wears out your ways is emery cloth dust, fine chips, grinding stuff. So we're going to wipe these guys down and then oil everything back up again. Did you ever see those old South Bend videos, the black and white ones, where they're talking about the cleaning your lathe and everything like that?
In preparation for the job, the machinist makes sure his ways are free of dirt and chips and that his lathe is well lubricated.
Let me change the camera so we can see a little bit of a better angle. Alright, I'm finding this very difficult to film, so I'm just going to go handheld here. So as we can see, we're on 0, the tailstock end. I'm going to try not to shake the camera here. And as you can see, we've got movement. Solid 3/1000. Let me get a screwdriver and fix that. I made the adjustment now on the tailstock. Basically what I did was I loosened up the nut. I loosened up these. There's 2 set screws here. And if I was to tighten this, it would pull the tailstock this way. If I was to tighten the other one, it would pull the tailstock that way. So what did I have to do? The tailstock had to go that way. So I did it, I tightened her down, and you can see we're at 0 right there. And as we slide her down, again, my apologies for a shaky camera here, and we're all the way at the end, dead nuts. So we're accurate now, and we're ready to go. So I'm going to remove this, I'm going to put the 4-jaw on, and we'll begin. This piece was rough sawn and we have a little bit of a burr here. It needs to come off, so just taking a file, knocking that thing down so it'll sit nice in the 4-jaw chuck. Alright, that's pretty good. I'm going to dial this in, get it perfect, and then we'll set up for drilling and tapping, and then to turn down the diameter of this rear end. We got her dialed in real nice now. It's just kind of wiggling around that witness mark. So, a couple of tenths. That's good. We're dead center with the tool. We're ready to go. Alright, we're going to give this thing an initial face-off. Alright, now that's our center, that's our 0. So the first 1.25 inches is going to be the final diameter for the R8. This is what's going to sit and locate inside the spindle. And then the rest is going to be clearance, and then we're going to flip it around, and then we're going to cut our taper. Final dimension on this is going to be 949. Alright, we got 28 thousandths to go to bring this thing to final diameter. This metal is it's a little rough to cut with this high-speed steel. The finish is coming out so-so. So what I'm going to do is, we have 28 to go. I'm going to bring this down 26 thousandths. I'm sorry, 22 thousandths, and then I'm going to sneak up on it with this guy right here, the shearing bit. Now, if you ever seen one of these things in action, they make like steel wool. You could really shave the finish smooth. So we're gonna clean it up with this guy. So this is gonna be our 22 thousandths cut. Yeah, it'd help if I actually dialed the 22 thousandths in. Alright. 22. Let's try that again. I got the shearing bit in now. Now, because this is so delicate, what I did was I set my cross slide to 0. And now how I'm going to touch off is I'm going to actually slide the bit. Hear that? And I'm going to just touch off that way. and lock it down. Because if you look at this thing hard enough, it'll move. So I just want to be precise. I'm going to take my measurement now, and we only have to shear this down 1.25 inches, because that's the part that's going to be located inside the spindle. The rest of this is going to be undercut. So I'm going to take my measurement now and see how much we're going to sneak up on it, 2/1000ths at a time. Alright, that's 955, we'll call that. So that gives us 6/1000ths, just as we planned. So I'm looking at 3 passes of 2/1000ths apiece. So what I'm going to do is bring this thing into 2/1000ths and go for it. Oh man, it's making steel wool. You could see that, you could actually see some low spots in there. You see nice shiny band all the way at the end, and then the other shiny band, you know, 1/4 inch or so away, out from it over here. So there's this little void almost in the middle. All right, final pass. Oh my God. Woo-wee. That is a nice finish. $9.50. I got a 1,000th to go. I'll just polish that out. I mean, the tolerance is 940. It's a 1/1000th, so you could be either 949 or 949 and a half. Or I could just dial in another thou. What does the mic say? 945 and a half. Dead nuts. That's the power of the shearing tool. Alright, what I've done now is I've chucked up a factory-made Arbor in the 4-jaw chuck. Got it all set up. I moved my compound now to 8.5 degrees, somewhere around there, because the included angle for an R8 Arbor is 16 degrees 51 minutes. So half of that, right, would be 8, say 8.25, or 8 degrees 25. Yeah, 8 degrees. I'm looking at the print right now. I'm staring at it. So yeah, 8 degrees, say 25 minutes. So I set my compound over here, and I'm just snugging it down. Got my indicator on here, and really what we're going to do is we're using the compound, moving the compound back and forth. We're tracing this angle, and we make contact with it, and if once it stays perfectly at 0 all the way through, we know our angle is correct. So let's dial it in and see what we're getting right now. All right, from where I'm standing, that's dead on 0. So just slowly, I'm just turning this with the compound. Not trying to shake it or anything because the compound is just snugged. Alright, so we moved about 1/1000th of an inch. Actually, we let out 1/1000th of an inch, which tells me that it's going in this direction. Right, so I'm just lifting up here on my Allen key and just kind of tapping it a little, snugging it down, and I'm gonna bring it back here, reset it, and check it. Take out any backlash. Alright, let's go. And it's moving away. Not on it on this one. Same thing. Getting close. Got about another 1/2,000 to go. Still a little more. You know what happens is when you tighten down the screw to lock your compound, you know, it kind of throws it a little bit. I think we might have it on this one. It's maybe, I don't know, 4/10. I could probably get it a little better. Whoop, crap. Alright, let's move it. Let's reset it. Whoop. Take the backlash out of the compound and the indicator. The indicator has a little bit of backlash too. Oh, I like that. Oh, I just came off of it there, but look at that. No movement whatsoever. Perfect. We're dialed in. Yeah, baby. Alright, I just freshened up the tool there. I don't know if you could see it. I'm going to give this thing a better hone here. Broken carborundum stone. I was really upset when this broke. Love this stone. Now I'm going to just hone that flat that I put on here. Slight radius. Now I'm making contact with this. I'm keeping the force down to make sure that this straight edge is in constant contact with the stone. Wow, that's nice. That's sharp. I hope the camera will pick that up. Alright, we're ready. Alright, we got the other end chucked up in the forejaw now, and what we're going to do is face it and drill it. Lock our carriage down. I'm just feeding in a little bit with the compound. All right. Alright, I'm going to pull this out. We're going to chuck it on the rear end and put this in the center. Alright, we got our freshly ground and honed tool. I'm going to mount that back up into the tool post. I wanted this sharp, real sharp, to cut this taper now, because that's what's next, is to actually cut the R8 taper. Now to cut this R8 taper, what I'm going to do is I have my compound set at the right angle, and I'm going to just start nipping away at this right from the shoulder, bring it all the way down. I have my relief cut in here, and how I'm going to check this is, first I'm going to just measure to make sure that the whole length of the taper is 15/16 of an inch long. That's how I did the prototype, and it worked out really fine that way. So we're going to start and we're going to go for it that way. Retract the compound a little bit here to get some travel length out of it. I'm going to lock down my carriage. Alright, contact. Whoop. Man, you could hear the bearings on my motor just grinding. They definitely need to be replaced. I've been putting it off and putting it off because the thing is as heavy as the Titanic, and it's not a lot of fun to try to take that motor off the underdrive and mess around with it. It's going to be a big project, so I'm going to listen to that. Ugh, you hear that screeching? That's the sound of bad bearings. I'm going to go back with that faster speed. I'm kind of liking that better. Oh, got plenty more to go. I think this is going to be my last cut now. Finish cut. I'm just going to go real slow. I got my shoulder line marked here now. I'm going to rough turn this down. We're going to get the diameter turned down rough here of this stub. And then what we're going to do is we're going to finish this, bring it to final diameter inside the mill. That's going to ensure that the thing has zero run out. Alright, the arbor is going to live in the mill. It's keyed, so it'll always be in the same spot, same place all the time. That's how we're going to do it. So let's dial up. We're at an inch and a quarter right now, and I need to bring it down. Final diameter is going to be 7/8 of an inch. So we've got a little bit to go. Alright, this is the last 143 thousandths we're going to take off before we move it into the mill. Alright, what we're going to do is we're going to mount up the arbor with a dog, and we're going to cut the keyway in it. So let me get a dog. Alright, I have the arbor mounted in the dog now. I'm going to put it in the dividing head, and we're going to use this woodruff cutter to cut the keyway. spindle. All right. All right, let's get an exact measurement. Okay, being that I don't have a 5/30 seconds cutter, I have a 3/30 seconds cutter, we had to do a little bit of math. What I needed to do is I needed to touch off at the top and then bring the top of this, the bottom actually, of the cutter to the bottom of the groove that I'm going to cut. Okay? And then what I'm going to do is I'm going to bring it up to take up the rest of what I don't have and do it in 2 passes. So I did the math off camera and we're going to go for it. DRO. We need to go 3/30 seconds deep, so 94 thousandths. I'm going to put this guy in back gear. We're going to run it slow. Alright, but as we know, we have to run it in reverse. Contact, set our y-axis to 0, looks nice. Now we need to bring it up 62 more thousandths to make up for what we don't have. Or should I say down? Yeah. There's 10, 20, 30, 40, 50, 62. Drip goes right back into the spill master for recycling. All right, I think that looks real good. Oh yeah. Not too shabby. Alright, I'm going to take a file, I'm going to take the burrs off of this, and we're going to get it set up in the mill, and we're going to get ready to cut this final diameter.